Hey, what is up guys? Welcome to another video. In this video I'll be going over a couple of grade 9 questions sent in by Zubair, one involving circles and the other involving compound shapes. A lot happened over the weekend. I went away and I came back and well, I have some good news and bad news. The good news is that we reached 1,000 subscribers, so thank you very much for that. Thank you for liking my videos, for subscribing and for leaving lovely comments. It's really appreciated. And the bad news I'll go over at the end of this video. But right now, let's get straight into these questions. So the first question says, the diagram shows two circles on a centimeter square grid. One circle has radius 5 centimeters and center 0, 0. The other circle has radius 3 centimeters and center 0, 4. The two circles intersect at the points 3, 4 and minus 3, 4. Find the area of the shaded shape. Okay, so we have this big circle and this little circle above it, and then we need to find the area of this shaded shape here. So what makes this problem difficult? If it was just finding the area of the semicircle, it wouldn't be too much of a problem. But the thing that makes it difficult is finding the area of this segment in here. This is what we call a segment, this area of a circle, where, oh, that's not a very good line. Let me try to draw that a bit better. Where we have a chord across the circle, and inside that is what we call the segment. So we need to find the area of the semicircle of the smaller circle and then subtract the area of that segment to find the shaded area. So the way we find the area of a segment is to find the area of the sector that's part of. So this is a sector here where you have a chord. So you have two radii and they're joining the circumference of the circle. So the way we find the area of a sector is we divide the angle at the center by 360 and then times that by the area of the circle. However, we need to to find the area of that segment, we need to find the area of the sector and then take away the area of this triangle in here. Now, what makes it difficult to find the area of the segment is we don't have that angle in the center of the circle. Okay, I hope you're following with me so far. There's a lot of steps involved, but where can we start? Well, we need the angle in the center of this sector. This is where the diagram helps us, because in this area here we have a right angle triangle, and we know the lengths of the sides of this right angle triangle. We know the radius is 5 centimeters. We know this length is 3 centimeters, and we know this height here is 4 centimeters. Because we're told these points, we're told this point is 3, 4. So based on that point, I know the height must be 4, and I know that length must be 3. And I'm told the radius is 5, so I know this length must be 5. So given that I have this right angle triangle in here, I can find this angle in here, at the center here, using the trigonometric ratios. So let's start off with that. I'm going to draw that right angle triangle underneath. So here I have this right angle triangle, and I know this length is 3, this is 4, and this is 5. Now what I'm looking for is this angle in here. So I can use any trigonometric ratio you like, because we know all of the sides of this triangle. So I'm going to use sine. The sine of theta is the opposite side over the hypotenuse. What we mean by that is the opposite to the angle. So the opposite side to the angle is 3. The hypotenuse is the longest side, that's 5, so the sine of theta is going to be 3 over 5. Now, I don't want the sine of theta, I want theta itself, so I can take the inverse of the sine. So inverse of sine of 3 over 5, and that will give me the angle theta. So if I put that into a calculator, the inverse of sine of 3 over 5, that gives me a number which looks like 36.8698976458. 6458. and it probably keeps on going. Now remember, I probably don't need to write that many digits in my answer, but remember that it's good not to round off until the very end of the problem so you're getting the most accurate answer that you can. Okay, so I have a value for theta, which is this angle in here, but I need this whole angle, which is the angle of this sector, in order to find the area of the sector. So I need to multiply theta by 2 to get the angle of the sector. So theta times 2, that gives me 73.7397952, and I'll just stop there. That's enough digits, I think. And okay, so we have this angle of the sector. Then what I can do is to go ahead and find the area of this sector, and then find the area of this triangle, and then that will allow me to find the area of this segment in here. Okay, so let's start off by finding the area of the sector. So area of sector. Area of the sector equals, and this is what the formula looks like, theta over 360, where theta is any angle, not this angle in here, but any angle, multiplied by pi r squared. So we have a value, we have the angle of this sector in here, which was 73.739. Yeah, anyway, make sure you put all of those digits into your calculator, divided by 360 times pi, and our radius in this big circle is 5 centimeters. So the radius squared, that will be times 25. Okay, so put all of that into your calculator, 73.7397952 divided by 360 times pi times 25, and that gives you an answer of 16.0875277, and I'll stop there. Okay, now I have the area of the sector. Next I want the area of this triangle. So I have the height of 4 and I know the base is 6 centimeters. So the area of this triangle, the area of triangle is going to equal the base times the height divided by 2. So that's 24 divided by 2. That's going to be 12 centimeters squared. This should be centimeters squared up here. Okay, so let's just picture again what we're doing. Let's rub some of these notes out. Okay, so we are trying to find the area of this segment. We found the area of the sector, and we're taking away the area of this triangle in here. This triangle in red. Okay. And we know the area of the triangle is 12. We know the area of the entire sector is 16 point something. So we can subtract those, find the difference. So the area of segment will be the area of the sector, 16.0875277 minus 12, and we get an answer of 4.08, all of that basically. 0.875277. Okay, so that's the area of the segment, which was this area I shaded in blue. Now we want this area shaded in grey, so I can find the area of that semicircle, take away the area of the segment, and then we're done. So the area of the semicircle, will be pi r squared divided by 2. So that's the area of the circle, and we need to divide that by 2 to get the area of half a circle. So now the radius of the smaller circle was 3 centimeters. So this is going to be 3 squared is 9, so 9 pi on 2. Put 9 pi on 2 into your calculator and you get 14.13716694, and that goes on as well. Okay, so now I want the area of the shaded region. Area of the shaded region, and that's going to be the area of the semicircle, 14.137 minus the area of the segment, which is 4.0875. Okay, so now I'm shortening these just because I'm lazy and I can't be bothered writing out all of the digits in these decimals, but in my calculator I've put in all of those digits and I've put in all of those digits just to make sure my answer is as accurate as possible. So I've done that on my calculator and my answer comes out to 10.0496392214. And let's have a look at the question again. It says find the area of the shaded shape. There's no degree of accuracy. I think that's actually a mistake in the question. They should say round to 2 decimal places or round to 3 significant figures or something, just so you know what to round your answer off to. So I'll round this off to 2 decimal places, so I get an answer of 10.05 centimeters squared. And that is my final answer. So let's just go over again what we did here. So we had a look at this shape. Let's rub all of this out. We were looking originally for this shaded region. We said it was a semicircle minus this area of a segment in here. So I began by trying to find the area of the segment. In order to do that, I needed the area of this sector in here. So I found the angle at the center of this sector, then I found the area of the sector, then I found the area of the triangle in that sector in order to find the area of the segment. Then I found the area of the semicircle, then I found the area of the shaded region. So there's a lot of steps involved there. Definitely a 6-mark question. Let me know how you went with that question. Which steps did you find the most difficult? I would say probably finding the angle of the sector is the most difficult step there, and then finding the area of the segment. The second question says 7 identical squares are arranged in a row to form a design as shown. Adjacent squares overlap such that a corner of each one is at the middle of the other square. The width of the design is 24 centimeters. Work out the area of the design. Okay, so we have some tiles, and the entire width of all of those tiles is 24 centimeters. And one thing I noticed about this diagram is that we can break it up in different ways. So I decided to break it up into 4 squares touching each other at the corners. So here we can actually break this width of this diagram up into 4 different squares. And I'll just finish drawing this and then I'll kind of explain a bit better. So you can think of this diagram as actually 1 square here touching the corner of this other square, touching the corner of this other one, and then this last one on the end. And I'm just going to ignore the ones in the background for now. So the width of this diagram is actually 4 diagonals of these 4 squares. Okay, so here I have the diagonal of 1 square, the diagonal of another square, 1 more diagonal, and then the last diagonal. So how can I figure out the length of that diagonal? Well, I can divide the entire length by 4. So 24 divided by 4, that's 6, so I know one diagonal must be 6 centimeters. So that's where I started with this problem. And if I'm given the diagonal of 1 square, I can find the area of that square. Now we know the lengths of a square, the length and the width are the same. So let's say that A and A. and we know the angles in squares are 90 degrees. So what I have here is a right angle triangle. Let me draw that down the bottom. Let's do some working out. So I have a 90-degree triangle, and I know the diagonal or the hypotenuse is 6 centimeters, and I know that these sides have the same length. So I can use the Pythagorean theorem, and I can say that one side squared plus the other side squared equals the hypotenuse squared. That's what the Pythagorean theorem tells us. So I know that a squared plus a squared equals 6 squared. Therefore, two lots of a squared, I can combine those because they are like terms. 2 lots of a squared equals 36. Then I can divide all of that by 2, so a squared is going to equal 18. And then I can take the square root of both sides, so a is going to be the square root of 18. Okay, so I know the side length of these squares is the square root of 18. Then I can find the area of the square by multiplying the sides together or squaring the side length. So the area of the square is going to be the side length squared, so a squared. So that's going to be the square root of 18 squared. The square root of anything squared is just that number, so the area of the square is going to be 18 centimeters squared. There's actually a shortcut. If you're given the diagonal of a square, there's actually a shortcut. You can skip all of these steps here and take the diagonal, so the area is going to be the diagonal squared divided by 2. That's a formula to find the area of a square given the diagonal of the square. So we know the diagonal is 6 squared divided by 2, so 36 divided by 2 is 18. So there's a little shortcut if you knew that formula already. Okay, so I know the area of one square, and in this diagram I've broken it up into 4 squares touching each other at the corners. So I know I need the area of 4 squares, and then in here I've got some little squares in the background here. And this is 4 quarters of one square, so that's going to make one whole square, those areas in red. And then I've got 2 more quarters of a square here. So in total I need the area of 5 squares and a half. So 5.5 squares will give me the entire area of this shape. So I can take the area of one square, so the area of the region, what are we calling this? The area of the design. Area of the design will equal the area of one square times 5.5. So 18 times 5, that's 90, and then half of 18 is 9. So 18 times 5.5, that's going to be 99 centimeters squared. And that's the final answer there. I guess the difficult part was figuring out how to kind of break this diagram down in a way that made it easy to figure out the areas, the different areas of the shape. This was just one way to do it. If you found another way of breaking up the shape, then I'm sure that would work as well. Okay, so now some of the bad news that I mentioned at the start of this video. I had a video taken down due to copyright. This was a video going over past papers. I didn't actually know that this was kind of frowned upon by anybody. I've seen so many videos on YouTube going over past papers. I just thought that it was okay and it was accepted. And so I got a copyright strike by YouTube. Apparently Edexcel asked YouTube to take my videos down. They didn't. Edexcel never messaged me, they never reached out to me, and I wish they kind of had, because I just would have taken the video down straight away. They never messaged me, they went straight to YouTube and asked them to take the video down, which is fine. If they want to do it that way, that's completely fine. I would have loved for them to have messaged me, but they didn't. So I'm sorry about the videos being taken down. There's nothing I can do about it. They won't be going back up because then I would probably get in some kind of trouble. I don't know. But yeah, I'm not sure if I can do past papers anymore. I have to have a look at all the copyright laws and, I don't know, speak to a lawyer or something. I don't have much of an idea about the legal side of going over past papers, so I won't be going over any past exams for a while until I figure all of that out. So I'm really sorry about that, and I know that a lot of people found them useful. I got so much positive feedback for those videos. Most of you subscribed to my channel found me through my videos going over past papers, so I know that you find them really useful. The weird thing is that I can provide those for my students at my school, but I can't post them on YouTube for students at other schools. I don't really understand the reasoning behind that. But there you go, that's the situation with my videos and copyright and everything. So once again, I apologize, there's nothing I can do about that. Other than that, thank you for watching. I hope you found this video useful, and I'll see you in the next one. Bye for now.